Hello, my name is Tyler Moore, and this is my XFOIL project video. So for part one, I'll demonstrate part one using a Naka airfoil. So we'll do that here. Naka 0015. We'll use paneling parameters by using the pane command. Edit the number of nodes by using the PPAR command. It will also show us our airfoil. So we'll change N to 250 and T to 1. That changes our panel density ratio. Hit enter twice to move on past that step. We use the OPER command, which defaults to an inviscid flow, but we want a viscous flow. So we'll change that using this command here. And for this part of the project, we're using a Reynolds number of 1 million. I'll change the iteration count to 100. Use the PACC command to establish a new save file. We'll do that, and we can name it something like this. Hit enter twice to move on. And then finally, to run XFOIL, we'll use the alpha sequential function. We'll go from -5 degrees to 15 degrees with a step size of 1. We'll hit enter, and that'll run that. We'll get our information here, and that'll save to a file that we specified. So part two is similar, but we're going to use an airfoil from the web, and that's under the file name clarkw.txt. So we'll load that up. It'll ask us to enter an airfoil name. Do that, and then from there, it's a pretty similar procedure to part one. Use the paneling command. Change the geometry a little bit. This is the airfoil we're using. 50 T1. Enter twice. Iteration, viscous flow. We'll demonstrate the laminar flow like we did in the project. That'll be Reynolds number of 300,000. Iterations to 100. We'll establish a file name. And we'll do the same alpha sequential function from -5 to 15 with the step size 1. And we can see our data coming in here. Now, I'm not going to wait for that to converge since this is just a demonstration, but you get the idea. Then we'll move on to part 3 here. Same sort of procedure, but this time we're going to be adding flaps. So load the same airfoil, the same name. Now, here before we do anything else, we want to designate our geometry. So use the gdes command for that. We'll tell it to add a flap. It'll ask us where, so we'll put that 0.7 in the x direction. We use the 999 command to add a relative y location. That'll be 0.5 for our purposes here. Then I'll demonstrate the 10 degrees down. Then we'll use the execute command to get out of that. And then from there, it's a pretty similar procedure. We use panel command, change the number of nodes to 250. The panel density ratio to 1. Hit enter twice. For this part, we're using Reynolds number of 1 million again. Iteration count of 100. Name our file here. Hit enter. And then we'll use the asequential function again. -5 to 15 is a step size of 1. And we can see our data show up. All right, I think that covers all 3 parts of the project. Thank you for watching.